Hello everyone, we are from Group J. Today we're presenting a mixed assembly program that demonstrates user input validation and number conversion into binary, octal and hexadecimal. Our team members are Ahmad Akil, Chakrapong, Wan Muhammad Akil, Faris Danish and Aiman Hakimi. We go line by line to explain what each part of the code does. Let's start with the data segment, which is explained by me. I explain the data segment, which is where we define all the constants and data our program use. For the line number 7, this mark the start of the data segment where we define strings, memory space, and other static data used in the program. For the line number 8, this defines a null terminated string that prompts the user to enter a number. For the line number 9, this string is displayed when the user inputs an invalid value. For the line number 10 until number 12, this line, these strings are labeled for displaying the binary, octal, and hexadecimal result, respectively. For the line number 13, this defines a new line character used for formatting outputs. For the line number 14, this defines a space character, also for formatting purposes. For the line 15, this allocates 40 bytes of space for an array to store up to 10 integers, each 4 bytes wide. Now, let's move on to the text section, which is explained by Faris Danish.
Now I'll be explain the main section. So starting at line 19, the program start by initializing the sign T1 to 0 to track offset in the numbers array. These ensure inputs are stored in sequence. So at line 21 to 28, the program use system call to display the prompt. The program use system call to display the prompt message and then read the integer input from the user. The input is temporarily stored in $T2. At line 30 to 32, the program checks if the input is within the valid range 0 to 255. If the input is out of range, it jumps to the invalid label to display an error message and restart the loop. At line 34 to 38, the program checks if the input is within the valid range. For valid input, the program calculates the appropriate offset in the number array and store the number. It increments the counter $T6 to track how many input have been entered. If 10 inputs are collected, the program proceeds to the last input label. Finally, at line 40 to 49, the program will display the number in different format. After storing each valid input, the program calls display number, which handle the conversion and display of the input in binary, octal, and hexadecimal format. Now I'll be pass on the presentation to the next presenter.
Okay, thank you, Faris. Hello, everyone. My name is Chakrapong, and I will explain the code segment that display a number in different formats. Let's go through it step by step. First is the main routine, which is display number. This is the central function that manages the displaying of the number in various formats. It prompts the user and calls specific subroutine. The first is load immediate $sign with 04. This prepare for a string output system call. The next line is to load the address of the binary prompt string into the $sign A0, and then syscall to output the prompt, and JAL display binary to call the binary display function. Next is display octal. Similarly, the octal prompt is displayed and the number in $T8 is passed to the display octal function. Next, we are displaying the hexadecimal. For this function, the hexadecimal prompt is shown and the number in $T8 is directly printed using the system call 34, which is specifically displaying a number in hexadecimal format. Next is printing a new line. This ensures for proper formatting by adding a new line after each section. Finally, jump input loop. This control return to the main program loop. After that, we look at the binary display function. This subroutine convert the display the number in the $T8 as 8-bit binary value. First, we initialize the $T0 and set it to 128, which act as the mask for the most significant value. Most significant bit. Next is the loop through the bits. We use the AND operation to check if the current bits in $TH is set. If not, the program jump to print 0. Otherwise, it print 1. Next is shift the mask and repeat. This is in the continue binary. The mask is shifted 1 bit to the right using SR1 and the loop continue until all bits are checked. Next is print new line for better readability. This is the end of the function. After the binary value is printed, a new line is added for clarity and the function returned to the caller. After that is display octal. This function extract octal digit from the input number, store in the array in the reverse order, and then print it in the correct order. First, at the start of the function, we setting up the variable. $T0 set to 0, which is to keep track of the number of octal digit. $T9, a copy of the input, which is $A0, so that it can be manipulated without losing the original value. And after that, $T3 point to an array used to store octal digit. After that, load immediate T5, 10 until the BGTZ $T5 clear storage. This is a loop that clears 10 slots in the numbers array by writing zeros. While optional, it ensures no residual data interfere with the result. After that, we extract the octal digit. This is the main loop extract the octal digit, isolating 3 bits at a time. It starts with load address $T3 numbers until ANEZ $T9 reverse octal loop. At N immediate $T1 $T9 7, this line isolate the last 3 bits of the $T9. Next line, it store this digit in the array. After that, it shift $T9 right by 3 bits to process the next octal digit. This process continue until all bits in the $T9 are processed. Next, we print the octal digit in reverse to make it correct order. It start with the sub $T3, T3, 4. This adjusts the $T3 to point the last store digit. Next is load word $T1, 0, $T3. This load a store digit to $T1, and then we add $A0, $T1, 0. This convert the digit to its ASCII representation for printing, and then the loop continue until all digits are printed. Then we add a new line. Then we return to the caller using JR $RA. And that's all from me, and I will pass it to the next member. Thank you.
Yeah, thank you. So now I will be talking on on how the last input is handled. So so on line 149 to line 153, the last input will be stored in an array. And then on line 155 to line 157, which is the input will be stored into dollar sign T8 before jumping into the display last numbers label, which is located on line 159 to line 170, line 185. On this label, line 159 to line 179 will convert the inputs into binary, octal, and hexadecimal before displaying it in a formatted manner. Line 181 to line 85 will print a new line before jumping to the exit label, which is on line 187 to line 189. The exit label will simply exit the program. Now I will pass it to the next person.
So now we will do the part which we will print the output. There are two parts, which is valid and invalid input. So if for now we will run it. So okay, if we enter invalid input, which is number between the range 0 and 255, we will get the result for the binary, binary, octal, and hexadecimal for each number. We will do it 10 times based on the question. Okay, that's for the valid part. Now for the invalid part. For the invalid part, we will enter number that out of the range. When we enter a number that out of the range, the system will ask us to enter the new number again. Okay, so that's all from us. Okay, that's all from us. Thank you for all your time and attention today. We hope our presentation provided valuable insight and sparked meaningful ideas. As a group, we have worked hard to deliver a clear message, and we are confident that the information shared will contribute to your understanding. Once again, thank you for your engagement and for allowing us the opportunity to present. That's all from us. Thank you.